Self-assembly is a process in which a disordered system forms an organized structure without external direction. It usually happens at a nanoscale, so in this video, we use hydrophobic sand to analogize and demonstrate this phenomenon. What happens when you put sand in the water? As you can see on the beach, it becomes wet and sticky, and it sinks to the bottom. But look at the colorful sand castle here. The sand perfectly stays the shape and creates a beautiful underwater kingdom. You might wonder, how do people do that? Well, let's try it with some magical sand. We prepared glass, sand, waterproof spray, coconut oil, and then we mix the sand with the spray. Let's check this out. The sand successfully stayed the shape we wanted, but what's the reason behind it? The magic lies in the spray we used. Its main components are non-polar, meaning their negatively charged end and positively charged end are not separated. When this spray coated the sand, it makes the sand wants to stay away from the polar molecules, which in our case is water. This water-resistant behavior is called hydrophobic, and the sand wants to stick together to limit the contact area. By doing so, the sand can maintain a shape. But we don't see this in oil environment. This is because there is no hydrophobic effect between the two non-polar molecules. Therefore, sand can freely distribute themselves in oil. The self-motivated behavior in water resembles the self-assembly process in nanotechnology. Self-assembly requires 4 elements. It requires a specific environment, structured particles, binding force, and driving force. In our case, sand is the particle, and in the water environment, it is binded through capillary action under the influence of gravity and hydrophobic property. So you might ask, why this is important? Besides creating beautiful underwater castles, for one example, self-assembly can be used in 3D printers to create awesome structures we need that can be hard to be processed through other manufacturing methods. Thanks for watching.